All right, so here we are on the Pythagorean Theorem / trig problems. And again, I already set them up. We just need to kind of do the calculus part on them. So in the first one, there's a ladder leaning against a wall, right? Here's that red ladder on the wall. And it's 10 feet long. It's sliding down, right? So as time goes on, this base is going that way. And that means that this has to go that way, right? And they tell us dx dt is 1 foot per second. And we know it's positive because the x distance is increasing if the bottom of the slider is sliding away, right? If for some reason the ladder was going towards the wall, then we would make dx dt negative. And we want dy dt, right? How fast is it falling, right? Maybe you want to know, like, well, if you got, if you're laying underneath there, how hard is it going to hit your head or something like that? And see if you can survive. So we have this equation, x squared plus y squared equals 10 squared. Now, this is something that we kind of need to talk about. Like, why was I able to go ahead and submit or substitute 10 in there? And the reason is because that ladder's length is a constant. It's not changing, right? The length of the ladder is not changing. It's not becoming a bigger ladder or a smaller ladder. It's the ladder that it is. So because it's a constant, I can go ahead and plug it in. But let's just think about this real quick. If I didn't know that, then I would want to go ahead and leave this. Like if I'm not confident that it's changing, then I would go ahead and leave this as h squared. And let's just do that for a second to see how it turns out, right? So because I want dy dt, I need to take the derivative of this. So we're going to go ahead and take the derivative. The derivative with respect to t of 2x squared is 2x dx dt. The derivative of y with respect to t is 2y dy dt. And the derivative of h with respect to t is 2h dh dt. Right, so that's my equation, and now I just basically need to plug in numbers for the things I know. I want dy dt, right? So I'm not going to plug in anything for that. Right, so I'm just replacing those with a bunch of parentheses. I'm going to replace it with what I know. I know dx dt is 1, so I'm going to replace that with a 1. I know that x is 6 at the time we want to know it. I know that h is 10, so I'm going to plug that in over here. I don't know dh dt. We're going to figure that out in a second. And I don't know y. So let's figure out y, right? Y is this height of the ladder at when x is 6 and h is 10. So this is the Pythagorean problem, right? Y squared plus 6 squared equals 10 squared. We're going to solve this. Y squared is going to be 100 minus 36, which is 64. So y is going to be 8, right? So this is 8. Put that there. And now if we did it this way, then we're still missing this dh dt, and there doesn't seem to be like a reasonable way to find it. And the only way you have to think about it is, what is dh dt? Well, what dh dt is the rate of change of h with respect to time, or how is the length of the ladder changing as time goes on, right? The change in h over the change in time. So let's think about this. As time goes on, how is the length of my ladder changing? And hopefully you're thinking, like, it's not changing, right? The length of the ladder is not changing. Therefore, the rate of change of the ladder, the dh dt, is 0, right? So this whole right-hand side becomes 0, which is exactly what would have happened if we would have started with 10 squared up there. When we took the derivative of 10 squared, because it was a constant, we would have gotten 0, right? But so you can see you can kind of do it either way. It would have been easier in the beginning because I wouldn't have to think about it, but we did it here anyway. Right, and all that's left for us is to solve this equation, right? This is going to be 12 plus 16 dy dt equals 0. Now we're just going to subtract 12, divide by 16 to get dy dt equals, and then we'll simplify that as well, right? Negative 3/4. And the units are dy is measured in feet, t is measured in seconds. So again, that's negative 3/4 feet per second. All right, going on to airplanes. Two airplanes start moving from the same airport. One's traveling south, right? South is down, so that's going to be this blue one here, y. The other one's traveling west. West is left, so that's going to be this x. We want to find the rate at which the distance between them, that's going to be, I called it h, like hypotenuse. I probably should use d, but then you get this like dd, dt, which is kind of weird, so I just use h. And we want to find the rate at which the distance between the 2 planes is changing, so dh dt. This is a Pythagorean Theorem problem. X squared plus y squared equals h squared. And here's a good example where I can't just substitute a value for h. And the reason I can't just substitute value for h is because as x and y change, h is changing, right? It's not like the latter problem where it's not changing. H is getting bigger and bigger and bigger. It's changing, so dh dt will not be 0. So I can't substitute it in right away. Right, so something like think about, like if it's a constant distance, then you can just substitute that number in there right away. But if that distance is changing, then you have to leave it, the variable in, and plug in after you take the derivative. All right, so we know this is our equation. Let's go ahead and take the derivative. We're going to get to 2x dx dt plus 2y dy dt equals 2h dh dt. And then I need to plug in these things that I know. So we're just going to have 2 parenthesis plus 2 parenthesis equals 2. Oh, sorry, we want dh dt, right? So dh dt is over here. That's the only thing I'm not going to plug in for because that's the thing I want to know. So we're going to leave it over there. All right. So what are the things do I know? Do I know x? It's tempting to put 400 there, right? But x is not 400. X is dx dt is 400, so that goes here. And then here it's 2 times y. I don't know y yet. We're going to think about it, but I know dy dt is 300. And then 2 times h, which again, I don't know what h is. So I need to find x, y, and h. So this is what this requires. Let's think about this. These planes started at some point, right? The one going south is traveling 300 miles per hour, right? So you can imagine after 1 hour, they went 300 miles in 1 hour, right? And then if they continued going, the next hour they would go 300 miles for a total of, right now, 600 miles, right? And then if we continued going after 3 hours, they would have gone another 300 miles in 1 hour, which makes a total of 900 miles, right? But this continues going until 10 hours, right? So like, well, how many miles would they have gone in 10 hours? Right? Well, it's just basically multiplying 10 times the rate, right? So the y value here is they're going 300 miles per hour for 10 hours. So it's 300 times 10, and you're going to get, it's cool how the units work, right? 300 miles per hour times 10 hours equals, notice how these units are going to cancel, and we're going to get 3,000 miles. So that's 3,000 here. And you can use the same reasoning to find x, right? They're doing 400 miles per hour for 10 hours, so it's going to be 4,000, right? 10 times 400, 4,000. Now h is not as obvious. H, we need to figure out h, right? So now I have this triangle. Let me erase some of this stuff so I have some space. But I have this triangle where after 10 hours, my triangle looks like this, right? It looks like, oh, this is 4,000. No, sorry, this is, the y is 3,000, the x is 4,000, and we want to know, well, what's this, right? So again, this is the Pythagorean Theorem problem. And so you could do 3,000 squared plus 4,000 squared and take the square root of that, or you can kind of recognize that this is a 3, 4, 5 triangle, special right triangle, right? So it'd be 3,000, 4,000, 5,000, and so the h is 5,000. Right, and you plug all this, you do all this stuff on your calculator, right, or in your head if you want, but it's basically 2 times 4,000 times 400 plus 2 times 3,000 times 300 equals, what is that, 5 million, and we're going to take that 5 million and we're going to divide by 10,000 because that's what we get on the right hand side, right? So we're going to take it and divide it by 10,000, and we're going to get 500, right? Basically, just after solving this entire equation, we get dh dt equals 500. 500 what? What is h measured in? It's measured in miles. What is t measured in? It's measured in hours. So it's changing at 500 miles per hour. That distance in between those two planes is changing at 500 miles per hour. All right, continuing. Rocket. So here, the picture over here, I did my best. We have an observer, which is this red dot. He's 700 feet away from where the rocket is blasting off, which just seems a little bit dangerous. Maybe it's a small rocket. But anyway, the rocket's shooting up, right? Here's my rocket going up, and we're calling that variable y. Though going up is y. And he's going up at a velocity of 900 feet per second. So dy dt is 900 feet per second. And we're assuming it's just going to go straight up, that it's going to create this 90-degree angle here, right? And we're interested in, well, how far is it from the rocket to my eyesight, right? This green line of sight, how far is that changing? Like basically me to that rocket, how far is it changing? So that's dh dt, where h is like the hypotenuse. So we have this equation, x squared plus y squared equals h squared. For sure, h is not a constant in this because it's changing. If you think about it, though, there is a constant here, but I guess let's wait. Okay, so because we want dh dt, we're going to go ahead and take the derivative. We're going to get dx, 2x times dx dt plus 2y times dy dt equals 2h times dh dt. And we're going to start to try to plug in some of the things that we know. Except for dh dt, because that's the one that we want. Right? We don't want to plug anything for dh dt because that's the thing we want. Do I know x? Yes, I know x. X is 700. Do I know dx dt? Let's think about it. Dx dt is the rate of change of x with respect to time, right? So how far is the distance between the observer and the place where the rocket took off from changing as time goes by? And the answer is it's not, right? The person is not walking back and forth. He's staying exactly where he is, right? That distance will remain 700. So the rate of change of the distance with respect to time is 0. It's not changing, all right? So I could have just substituted that up there knowing that it was a fixed quantity, but we can do it here too. Now dy dt was given to us, that's that 900, and y was given to us, that's that 2400. So it's when we get to the other side that it becomes a little bit complicated. We have 2 times h, which we're like, we don't know what h is, but again, we know what x is, we know what y is. The Pythagorean Theorem, we're going to find h, right? So to find h, it's going to be h squared equals 700 squared plus 2400 squared, right? I know x is 700, I know y is 2400. We just got to do that. So 700 squared plus 2400 squared equals that, and we take the square root of our answer, and we get 2500, right? So this is h is 2500. So we're going to put that right here, 2500, right? And then we, solve this equation. This whole piece is 0, so it's this little piece here left. So 2 times 2400 times 900 is going to give me 43,000 equals 5,000 dh dt. We divide both sides by 5,000, and you get 8.64. Sorry, I messed the number up here. Let me try this again. 2 times 24. Oh yeah, I did a 240 instead of. I always did the wrong numbers up there. It's 2 times 2,400 times 900 for the left-hand side, and you get 4 million. So I'm missing some zeros here. And so then when you divide these, you should get 864 feet per second is what dh dt is. I just left out some zeros. All right, there you go. That's that one. Moving on. Trains. This is very similar to the problem above. Trains are going in two different directions. The one going north is going at 50, that's dy dt, because I labeled that north distance as y. And then the one going east is going at 40 miles per hour. And I labeled that one x. And then again, the distance between them is going to be h, and we want to know dh dt, how fast is that distance changing. So our equation again is Pythagorean Theorem. And again, when we take the derivative, we get that same thing that we've always been getting. And we plug in the numbers that we want, right? We put x there, dx dt there, we put y there, we put dy dt there, we put h there, and we want to know dh dt, so we don't touch that one. and we plug in what we know, right? So what do we know? We know that x, we don't know what x is. We know dx dt is 40. We know dy dt is 50. We can figure out x, right? This is the same thing. dx dt is 40 miles per hour. It's going for 3 hours. So 40 miles per hour for 3 hours is going to be 120 miles. Yeah, 40 times 3. Then y is changing by 50 miles per hour for 3 hours. 50 times 3 is 150. So the y is going to be 150. And we have this new triangle over here that's 120, 150. Right? And we want to know what's this distance. Pythagorean theorem, right? 120 squared plus 150 squared will give me h squared. So 120 squared plus 150 squared is going to give me that, and we take the square root of that and we get 192. So h is 192.093. That's what goes here, 192.093. And then we solve this whole thing, right? We, on a calculator or however you want to do it, 2 times 120 times 40 plus 2 times 150 times 50 is going to give us 24,600. And we divide that by the right hand side, which is 2 times 192.093. And we get 64.031. Remember, 3 decimal places in calculus, round or truncate. This is what dH dt is going to be. And h is measured in miles, time is measured in hours, so miles per hour. Or you can write mph if you want. And that's how that one goes. All right. Continuing the balloon problem. Here's the situation, right? We have this red rope attached to a balloon. There's a vertical distance to the ground, which we're going to call y, and there's a horizontal distance from where the person is standing to where the vertical distance would touch the ground if like you look straight down, right? So it is a right triangle, and what it's saying is that angle is always 60 degrees, right? That angle between the rope and the ground is always 60 degrees, which is super helpful. And we're given that the balloon is being pulled in at 5 feet per second. So that because the length of the rope is decreasing, it's going to be negative 5 feet per second. And we want to know how quick is the balloon's elevation changing. Because y is representing the height, we want dy dt, right? You could easily call that like h or something, but I used y. All right, so we have this equation. It's not Pythagorean theorem because we don't know all those distances. And we know that angle, so actually you want to think of like, well, what relationship can I create between that angle and x and y? And the answer is it's a sine relation, or what the heck? Yeah, it's a sine relationship. It's not between x and y, it's between y and r, right? Sine is opposite over hypotenuse, so sine of 60 would be opposite, which is y, divided by the hypotenuse, which is the rope. So sine of 60 equals y over r. And just to simplify this so we don't have to use quotient rule, let's do that. Right? R sine 60 equals y. And then we're going to take the derivative on both sides. Because we want to know dy dt, right? I have y and I want dy dt. I want to know the rate of change. That's what the derivative tells me. So the derivative of r with respect to t is dr dt. Right? Okay, so sine of 60 is a constant, and maybe let's go back real quick because I know that's going to confuse people. So before I take the derivative, let's do this because this is going to confuse you otherwise. What is sine of 60, right? Sine of 60 is, if you're on the unit circle, 60 is up here, right? Sine is this y coordinate, which is the root 3 over 2. So really, this can be simplified to root 3 over 2 times r, right? And then now I'm going to take the derivative. So the derivative of root 3 over 2 times r is root 3 over 2 times dr dt, and that's going to equal dy dt, right? And so we have root 3 over 2 dr dt equals, oh no, and then we're going to plug in a number, right? So I know dr dt, right? So I'm going to plug in a number for dr dt. dr dt is -5, and that's going to help me find dy dt. So this is going to be -5 √3 over 2 what per what, right? In this case, y is measured in feet, and time is measured in seconds. So -5 thirds, -5 √3 over 2 feet per second. All right. And that's all the Pythagorean theorem examples. So I'm going to make a new video for the other ones.